Right. Welcome back. Let's take a look at the steps it would take to configure storage IO control. Now, one thing to note when it comes to storage IO control, while it is disabled by default, when you enable it, make sure you test it first. Put it in test environment. Make sure what it is that you're doing is actually going to improve things, not just on that data store, but if you have other data stores that are actually backed by the same storage pool, that's where you really need to just kind of watch to see whether or not this would improve things, because it should, but there's always that, you should test it first, right? It's a little bit different than network IO control, where network IO control is actually enabled by default, and there's really no negatives with network IO control. With storage IO control, if you do have a group of data stores all with storage IO control enabled, and they're all backed by the same storage pool, that may not always be the most positive impact. When storage IO control is trying to impact one data store, what might that do to another data store that's backed by the same actual spindles? So just test it first. So how would we go about setting this up? Well, it's basically a two-step process. Step one is to actually go ahead and enable it on the data store. And then step two is then to assign your virtual machines with the appropriate storage policy component for it. So let's take a look here. I'm going to switch over to the lab environment. Okay, so in our lab environment, what we need to do is go to the storage section and find your different data stores. Now remember, this can only be a VMFS or NFS in a SAN or in a NAS configuration. So this does not apply to a vSAN data store, and it doesn't apply to a local data store. While the option is there, it won't really take effect. But for instance, on a vSAN data store, if I click on configure, you'll find there's no options here for storage IO control. It doesn't exist. But if I click on a VMFS data store, that's in our SAN, right? So we have here, you'll see there is a storage IO control setting. It is currently disabled, which is the default setting. So let's go ahead and enable it. So you select edit, and then it is disabled. So we click on enable. And notice you have your two choices on how it monitors for congestion. It'll by default use this percentage of peak throughput, so 90% is the default and recommended setting. You'll find that there are other settings, but we really recommend leaving it here, but that is the recommended at 90%. Minimum, you can actually only set it down to 50%, which I guess you're not really using that much of your throughput if you're only at 50% of it. So leave that there. If you'd rather do the old-fashioned way, notice it even tells you, hold on a second, before you do this, be aware that setting improper congestion threshold values could be detrimental to the performance. So we really don't want to have you watch out for this, right? And again, if you're doing this, you really need to know what all the different, parameters of your storage, right? The adapters, capabilities, your network capacity, the disk speeds, and so on, to find what is a good number to indicate there's congestion. That's why this is more automatic, right? Set it to the percentage of peak throughput, and then it doesn't matter what your speed of everything is. It will just determine whatever that is. 90% of the peak throughput is going to be a point to monitor for congestion. And then that's it. You click OK, and now I have storage IO control enabled on my particular data store. The next thing we need to do is then assign policies to your virtual machines. Now, by default, all the VMs get 1,000 disk shares, and we're good, right? Already by default, any VM that's on this data store will be equalized no matter what ESX server they're sitting on. But what we can do, as you've seen me do before, you go over here and find the policies and profile section. Now, when you talk about storage about storage IO control is a filter. So how do you set up filters? Well, that's actually what we call storage policy components. And there are several built-in ones. So for instance, we see and we have two vCenters here, so that's why we see double the count here. We see the default encryption, that's a different filter, but we have the three that are related to storage IO control. There's normal shares allocation, there's high, and then there's low. Basically, the difference here is high is twice as good as normal, and normal is twice as good as low when it comes to shares, right? So for instance, if I look at normal, it'll show me down below here, that is 1,000 IOPS shares. If on the other hand, I look at high, it's going to show me that that's 2,000 IOPS shares. And if I look at low, well, that's going to show me that that's 500 IOPS shares. Now you notice something else though. These built-in components also come with some IOPS reservations and IOP limits too. So we have 10 and 1,000 for the low. Normal bumps that up to 50 IOPS reserved and 10,000 at the limit. And then high sets that to 100 IOPS reserved and 100,000 as the IOPS limit. So you have some upper and minimum requirements here that are built into these components. But these are just components. You still need to actually apply them in a policy, right? So if I go look at my storage policies, you'll find, okay, well, there are a whole bunch of policies in here, but there aren't any in here that have anything to do with storage IO control, right? So you'd have to actually create one. Now, what's neat here is that I could tie my storage policy components with regards to maybe some placement policy if you want to, or I can actually just set up a basic normal storage priority. All right, just create a policy that's just going to be called normal storage priority. So it doesn't really matter what data store they go to, but it will indicate that the VMs who have this policy will be equalized as they pass through that host. So I could actually just specify, I want to create a host-based rule, which then says, okay, well, which storage policy would I like to use? So I'm not using encryption. I can set storage IO control and specify one of the built-in ones, right? I had normal, so let's just assign this one normal. Now, of course, I don't have to do that. I can actually go ahead and create my own as well. If I didn't want to use one of the three built-ins, I can go ahead and use this one. I could have actually created my own built-in one as well, right? There's the three built-ins, but I can create my own custom storage policy component and put that in here. That's the beauty of those storage policy components. They are easily used and reusable. But I'm going to go ahead and assign the normal IO shares allocation to my normal IO priority policy. Right? Now, every data store is compatible with that, because things about host policies or filter policies, they don't have any direct relationship to storage, right? They're agnostic to the storage. However, even though they did list every single data store in there, the vSAN one wouldn't matter, because vSAN actually doesn't participate in storage IO control. So now I have my policy. The next bit would be essentially going to one of my virtual machines and assigning the policy, right? So, pick any virtual machine and you select which policy. So you go to here to VM policies and you edit the policies, and I can just give my VM here my new normal storage priority, right? So again, it doesn't matter what data store he's going to. He happens to be some in upscale and he's got some in the 11 gigabyte remote. No matter whether it's, well, the 11 gigabyte remote, yeah, they're all on the SAN, so they will all have normal IO shares as they pass through the ESXi host. But this isn't actually having to do with how they get prioritized at the actual storage location. This is more of how we're going to deal with it as it goes through the host. So any VMs who have that normal policy will be essentially equalized. So let's go back to our slides. So our slides basically show the same thing, right? Storage IO control is implemented as an IO filter, which basically means you need to have a storage policy component in order to configure this. So we have those built-in ones like we just mentioned, high IO, low IO, and normal IO allocations. And again, you go ahead and assign one of those to a policy that we're assigning with some host-based services. So in this example, we're actually creating our own right here in the policy administration page, right? So we're creating some host-based services. We're going to go ahead and create our own, basically setting 1,000 shares without setting any of the other parameters. One IOP reserved isn't much of a reservation, and a -1 on the IOPS limit basically means there is no limit. So prerequisites. Storage IO control is supported only on data stores that are maintained by a single vCenter system, right? Because basically what we've done with storage IO control is we put vCenter in charge of all the IO across all the hosts that are trying to access the same data store. Having two vCenters would cause some problems there, right? We need central management. Storage IO control is supported for Fiber Channel, iSCSI, and NFS storage, right? It's basically VMFS or an NFS when they're on a SAN, right? Raw device mappings are not supported. vSAN, virtual volumes are not supported. It does not support data stores with multiple extents either. So that's also an important thing to note. If you've spanned your VMFS data store across multiple LUNs, each LUN actually has their own queue, which would really skew the mechanisms of what storage IO control is trying to achieve. You want to have a data store with just one LUN with one queue. And if your data stores are supported by arrays with automated storage tiering capabilities, then your array must be certified as compatible with storage IO control. Basically, what is this? When you have an auto-tiered storage array, there can be a LUN that gets created on that array that's backed by a whole set of different kinds of disks that the array can determine which type of disk should be where we place the IO for whatever the IO patterns are. So if you have busy VMs, they might get put on the faster disks. Less busy VMs might be placed on slower disks or something like that. That would skew with what IO control is trying to achieve. So as long as the array is actually informing vSphere of what it's doing, typically through VASA, then that makes sense. But if it's just an array doing auto-tiered storage tiering without informing vSphere, it's doing all this behind the scenes, then storage out of control can't see what it's doing, can't see what the auto-tiered storage is doing, and it will probably have a negative impact all in the end. So let's put this all together with an activity. Here we have a scenario where we have a data store with storage IO control enabled. What steps would you take to ensure that the online store VM and the mail server VM have higher IOPS than other VMs during periods of contention? Well, we pretty much just talked about this, right? We have 3 hosts, we got several different virtual machines. We'd want to make sure that our critical workloads, the online store and the mail server, are quote unquote VIP status, right? So what would we do here? Well, we already have storage IO control enabled, so we already have balance, because that's what happens by default. What we're trying to do here is grant high priority to those critical workloads. So essentially what do? You basically grant those VMs the high IO allocations shares storage policy component with some storage policy. Remember, you can't just give a VM a storage policy component. You actually have to create a policy and make the storage policy component that represents high IO shares allocation as part of that storage policy. So that's really what you need to do. Create a storage policy that uses the predefined storage policy component called high IO shares allocation, which gives the disk shares of 2,000 shares, and assign a storage policy only to the online store VM and to mail server VM. All the other VMs will already by default have 1,000 shares. So you don't really have to do anything else with all the other VMs. That makes this a little bit easier to manage. You only need to grant the high IO shares allocations policy to those VMs that need it, and then leave all the other VMs at their default settings. So that is a quick look at storage IO control. We've seen how to describe how storage IO control balances your IO load to a data store, and showed you the 2 main things you use to configure storage IO control, right? You enable it on the data store, and then you actually create a policy that's making use of one of those storage policy components and assign that to one of your virtual machines. So we'll take another quick break here. We'll come back and we'll take a look at the next lesson. See you in a few minutes.